Here is the first part of cyclic quadrilateral and its properties. What is a cyclic quadrilateral? A cyclic quadrilateral is a four-sided figure whose vertices are lying on a circle. Thus, A, B, C, D, it's a quadrilateral. Its four vertices, that is A, B, C and D are lying on the circumference. And the essential feature of cyclic quadrilateral is opposite angles. Angle A and angle C, they are the opposite angles. They sum up to 180 degree. Similarly, angle B and angle D add up to 180 degree. That is the fundamental property of cyclic quadrilateral. Now we shall try to understand the reason why the opposite angles add up to 180 degree of a cyclic quadrilateral. We shall do that in the light of our previous knowledge on angles subtended by a minor arc and a major arc in a circle. So let us start with angle A and angle C. Let us prove these two angles sum up to 180 degree. First, we join this point D with point B. That is a diagonal. DB is a diagonal which is also a chord for this circle. Now we know any chord in a circle divides the circle into a minor arc, that is DAB, and a major arc. Here it is DCB. Now let us recollect the angles subtended by the minor arc and the major arc. So minor arc DAB has subtended an angle DOB at the center. The center of the circle is O. We have joined point D with O, that makes one radius, and point B with O, that makes another radius. This angle DOB is subtended by the minor arc DAB. Same minor arc has also subtended an inscribed angle at point C on the other side of the circle, that is on the major arc. This we have found by joining D with C and B with C. Hope you now remember the relation between DCB and DOB. We know that angle subtended by an arc on the opposite segment is half the angle subtended by the same arc at the center. So angle DCB is half of angle DOB. So let us write that. Angle DCB is half the angle DOB. Now DOB, as we see, just for interest sake, is less than 180 degree. It is an obtuse angle subtended by arc DAB. Why do we say it is an obtuse angle? Because as we extend BO, we can see that the 180 degrees from here to here, but our angle is DOB is shorter than 180 degree. It is an obtuse angle. Now let us go to the major arc. The major arc DCB subtends an angle at the center O, which is bounded by the major arc on one side and the two radii BO and DO on the other side. Thus, this is a reflex angle subtended at the center by major arc DCB. Why do we call it reflex angle? Same. Look at the extension of the line segment BO and 180 degrees from here to here, but our angle is from here till here. So it is a reflex angle more than 180 but less than 360. Same major arc subtends an angle DAB on the opposite segment. Now we know the relation between this angle DAB and angle DOB subtended by the major arc, this reflex angle. What's the relation? Angle DAB is half of angle DOB here. So let us write angle DAB, that is this angle, is half the reflex angle DOB subtended by the major arc. Both are denoted by DOB. This is an obtuse angle subtended by the minor arc, and this is a reflex angle subtended by the major arc. Now let us see. If we add DAB with DCB, these two angles are our point of interest because they are the opposite angles of a cyclic quadrilateral. So let us add these two angles. So angle DCB plus angle DAB is equal to this plus this, that is half of the obtuse angle DOB plus half of the reflex angle DAB. Now we know that this complete angle around the center is 360 degree because angles around a point is always 360 degree. Now, so what is the sum of DAB and DCB? Which is equal to, let us take half common. One is reflex angle and another is obtuse angle. This together makes half of 360 degree, which is equal to 180 degree. So it is now proved that angle DCB plus angle DAB is 180 degree. The converse is also true. So in any quadrilateral where opposite angles add up to 180 degree, it will be a cyclic quadrilateral. So a square, a rectangle and an isosceles trapezium, they have sum of opposite angles as 180 degree. They are all cyclic quadrilateral.